Hey everybody, Lars here. Time for review video number 1 for Unit 5. Unit 5 is a big 3-week unit where we look at object-oriented programming. Before we get started, thank you everybody for all the well wishes on my leg. Actually, as bizarre as it sounds, things are looking up. I know it's been a hectic week. They stuck me in the hospital for a couple days because I had a blood clot in my arm and a whole bunch of other stuff. But the last couple of days, I've been walking in a boot. I've been able to drive. Today was the last IV I had to take because, my surgery was infected, so they put me on a course of antibiotics for a month. Today was the last day, so I'm done with all that nonsense. So things are looking up. Right now I got to let the reconstruction heal, the plastic surgery. And then once, I still don't have a working Achilles tendon, so once that heals up for a month or so, we're going to go back in and we're going to see what we can do about the tendon. Sometimes Achilles tendons grow back naturally, and maybe something will grow back that we can rehab. If not, we might have to go get a reconstruction done early next year. But I think hopefully I'm done with surgery for at least this year. I've had, 3 surgeries in the last 50 days, so I'm done with it. I'm not looking forward to having more, but I digress. Let's take a look at the beginning of Unit 5. Now, Unit 5 breaks down into 3 different weeks and 3 different things. I got you, it's Friday night now. I got you most of the material Monday, which isn't so bad because by the time you read the Zell and you look at the slides, 3-4 days is about right for that. So, like I said, I'm going crazy with Python this weekend. I'm going to crank videos out. I already did your Unit 3 grades. If you didn't get them, let me know because I think I've sent them to everybody and you should have your Unit 3 grades. Then Hans and I are going to grade some Unit 4 stuff. He's going to do the assignments. I'm going to do the quizzes and the forum posts. I'm going to grade the midterms this weekend, so hopefully I'm going to be getting you some feedback on your midterm papers. I'm going to crank out video number 2 tomorrow night, I think. So I got Python on the brain. I can't let this leg nonsense slow Python down because Python stops for no man. So we need to trudge along and we need to get this stuff done. And you know what? It's November 18th. Think about it. In a month, maybe 5 weeks, you're done. You're already Python programmers. I mean, once you get done with the assignment for Unit 3, you're a programmer. You're a Python programmer. So you're already there. Now you're just going to learn the nuances and some interesting stuff. And object orientation is kind of part of that. Let's see if I got the do I have the slides up and ready? I do. A lot of people will hear OOP or object-oriented programming or object orientation and think, what really is it? Now, so far, we've been doing things like a recipe, imperative programming, if you look it up, where it's like baking a cake. You have a set of ingredients. That would be your data. Then you do a bunch of things with your ingredients. That would be our commands and our if, then else structures and decision making and the different things that we do to our data, and then you come to results. So it's kind of like a recipe. It's kind of like your data is your ingredients, and then you have the steps that you take to get to your final goal state. But what if there were another kind of way that we could create programs? What if we not necessarily made a simulation, but created a situation where we were mimicking the real world and letting different aspects of that mimicked real world interact with each other? And it's almost like setting an initial state of a system and then just letting it go and seeing how things happen. And if we could craft a computer program to do something along those lines and to act how things act in the real world, we could almost remove that level of symbolism that we use. When we do imperative programming, we have to create our data, and our data is a symbol for things in the real world. Because remember, we're solving real world problems. So we have to go through that, intelligent step of creating data that symbolizes these things. And then as we run our logic on it, that logic really has to tie into how logical it would be to do those things in the real world. Well, I think object-oriented programming is sort of a way to not really remove that step, but bring it closer to the code and actually simulate and fake, not really fake, but represent an object in the code a little bit better. And you'll like a lot of things with computer programming. I probably sound like I'm nuts right now. When you see it in action, you're kind of going to understand what I mean. Because what we're going to do with object-oriented programming is basically we're going to set up blueprints. You can see my blueprint of a boat right there. And these blueprints are called classes. And what you can do with the blueprint is then you can take your blueprint, just like you would in the real world, take your blueprint and go make a real object with it. Make a real object, make a real object. So that one blueprint of the boat, I think I have the picture up here, you can make all kinds of different boats with the blueprint, okay? The things that make those boats different, size, color, materials, things, that's their attributes. And we'll be able to do that when we create our blueprints or our classes in object-oriented programming. We can use different data, and that data is basically a different attribute. So we can make a big boat, a little boat, a tugboat, an orange boat, a red boat, all kinds of different things just using a one base class. When you create classes, as you see if you read through the slides, you have the data, and then you have the things you can do with that data. So the data, like anything else, is just called data, but the functions that you can run on those data, if they're inside classes, we call them methods. And I always say it, I still don't know why. I don't know why you wouldn't call them class functions or functions on whatever, but we call them methods, okay? So as we run through the slide, you see data and methods, and then I go through the example that I give you in the slides of a die, okay? How to basically fake a die so that you would roll it and do all of that. But, and I always believe this is definitely the case with object orientation, I want to give you another example. I don't want to just sit here and review the dice class and go through the die. So what I usually do in the first video for Unit 5 is I whip up a class that fakes a bank account. So we are going to do that right now. Let's do that. Bank accounts. And first thing we're going to do is we're going to type the keyword class. And then I'm going to call it bank account. And then colon. And that's it. Boom. Okay. So when I create a class, what's the first thing I want to do? First thing I want to do is define that very first method in any class that we call the constructor. Okay. And I will do a lot of explaining when we run this code and trace through it. But basically, what I want to do is I want to name the constructor underscore underscore, 2 underscores in a row. Okay. Python programmers call them dunders, or double underscores. So you'll say dunder, init, dunder. And you're going to find out as we go through the road that these double underscores have a special meaning in Python. So don't use them with your own variables. You're going to see that they have a special meaning. So I want to define in my class the constructor. I give it 2 arguments. One is self. Self is a little nuanced. If you have experience with Java or C++, think of the keyword this. It is a way for the class object to refer to itself. If you think about it, I have a blueprint right now. I don't know what the actual object is going to be called. But when we do have a name for the actual object and we run this code, that's what self is going to be. Okay? So it's basically we're just saying to ourselves, hey, when this thing has a name, use it here. Okay? It's sort of a little placeholder. You're also going to see that when we call these methods, you don't have to put self in there. That Python's going to take care of that for us. It will all be understood when we run our code. You will see. All right. All right, when I start things off, what do I want to do? I'm just going to print, you have created a bank account. Thank you. Exclamation point. Why not? And then I'm going to create what's called an instance variable. So I'm going to say self.balance. And I'm going to make it equal to amount. You know what? That's it. That's all I'm going to do. So when I use this class to create an object for a bank account, it's going to run and say you have created a bank account, and whatever number I give it, it's going to set that instance variable, balance or self.balance, equal to the amount that I give it. Okay? So now that's it. I have a bank account. So you've read the slides. What's the next thing we want to do? We want to handle our getters and our setters. Now, getters and setters are things that are usually set for data items. So I have one, balance. I'm not really going to need a setter for it, because as you're going to see as I move forward, I'm going to set it by doing deposits and doing withdrawals. So in this particular context of a bank account, I don't really need a setter, but I am going to get a getter, because we can do that, because people are always going to want to ask what their balance is. So it is literally this simple. That's it. Okay? So when people who have an object that bank account is used to create run a method called get balance, it's just going to return the balance. It's just like you asking what the balance is of your checking account. Okay? Or savings account, doesn't matter. We are halfway there. What's another thing that we want to do with a bank account? Well, I know one thing we can do. We can make a deposit. Okay? When we make a deposit, we're going to want to say how much that is. So, if I'm making a deposit, I will say print. You have deposited amount, and then I will make self.balance equal to that and the amount. So I will add that to self.balance. Boom. And then we're done. Okay? So that's how simple that method is. Make deposit, self amount. I take the amount. I say you have deposited that amount, and I increase the balance by that amount. Piece of cake, okay? Now, the last thing we're going to do is we're going to say make withdrawal the same way. But this one has a little bit of a rub. Because if amount, I did Amy the last time I did this video too, if amount is greater than self.balance, then we're in trouble, okay? So we don't want to run into that situation. So we'll say insufficient funds, if that's the case. Else, now what does else represent? Else represents if amount is less than or equal to self.balance, which is fine, because then all we have to do is say self.balance minus amount, and then we've made the withdrawal. Another thing we should do, just to be the same as our deposit, is we will say you have withdrawn amount. Okay? And there we go. All right. Call me crazy. And I'm sure there's an error somewhere and I'm not seeing it, but I think we're good. Okay? So, we have, well, first of all, I'll save it, my goodness. We have a class called bank account. This class has a constructor. Okay? Constructor has two arguments. One is self, one is the amount we want to start our bank account with. I just print you have created a bank account and I set the amount. Okay? Boom. That's it. Then I have a getter, which just returns the balance of my bank account. So if I create, and you're going to see, we're going to use it in a second. You're going to go, okay, now I get it. We have a method called make a deposit. When you run this method with a certain amount, you will add this amount to your balance. Okay? You can make a withdrawal. As long as you put in an amount that's you can cover, you can take that amount out, withdraw it, and then take it away from your balance. Okay? So this is how a bank account works. I'm going to call the variable my account, and I'm going to make it equal to bank account, and I'm going to give myself $500. And I think that's all right. And then I'm going to print my account dot. You see, this is the way to run a method on an object. My object is now called my account. I created it in the line before. I said go use the class bank account and give me $500 because I know when I create a bank account object that I'm looking for amount. So I give it 500. Here, I just use the variable name and then the method name. Okay? And if I'm not mistaken, that'll create an account called bank account, and it'll say you have created a bank account, and then it'll tell me the balance is $500. Unless there's a typo. And there is. Of course things weren't going to run properly. Let's see what we got here. My account equals bank. It'd be nice to spell that correctly. Bank account. So it's spelled correctly there. Bank account. Now it is spelled correctly there. Let's see what we got. Yay. you have created a bank account 500. So basically, we're going to trace through this code, and I'm going to show you what the deal is. Class definitions are kind of like function definitions in that when they're above and they're red, they really aren't run, they're just put into memory. So when I come down here, comment, class bank account, I'm putting this into memory. So I have my constructor, where I just print you have created a bank account, and I set that variable. I have my getter that gets me a balance. I have a method called make deposit. I have a method called make withdrawal. This is all wonderful, but nothing's being run. It's all going into memory. Then I have a comment right here, main, and then final two lines are really the only two lines that do anything in this program. I create a variable. That variable is called my account, and I assign to it an object I create with the class bank account, which is what we have up here, and I give it 500, and 500 is going to be placed there. But let's go do that. It says bank account 500. So what happens? Python looks for a class called bank account. It finds it. It's right up here. And what happens when you create an object? You run that class's constructor. So def, init, self. What's self? Self is my account right there. Okay. Comma, amount. Print, you have created a bank account. What happens? Right here, you have created a bank account. Then self.balance, okay, equals amount. So amount was 500, so now the instance variable, or the variable that goes along with my account, is equal to 500. And that's it. Boom. End of story. Then in the second line, I print my account dot get balance. So what happens? My account. What is my account? My account is a variable that holds an object that was created with bank account. So we go to bank account and we look for a method called get balance. Does that exist? Yes, it does. What does get balance want us to do? Return self.balance. Well, what is balance? Balance is 500. We just said it in the line before. So I return 500. So I return 500 to this method call, and what gets printed? 500. Okay? So how can we keep going with our bank account? Well, what's the next thing I'm going to do? In a couple of weeks, I'm going to get paid. So I'm going to say my account dot make deposit, and I'm going to give myself $300. Rutgers pays me $300 a week. That's really bad. And then I'm going to print my deposit to see what I get. And you're going to see I've created a bank account. It's got 500 in the bank. But now I have deposited $300, so now I have 800. Okay? So that's how that works. You can see now maybe code like this working at a bank, or maybe something like this working to, give you an audit trail or something like that as you go ahead and do things. Now, I'm going to do two things. One, I'm going to give myself some room. Two, I'm going to say my account dot make withdrawal, and I will withdraw $100. And then I will print it out after that, and hopefully if that works, you'll see I've withdrawn 100 and my 800 goes to 700. Okay, so now I have $700 in there. So, oh sugar, I didn't want to do that. Let's see, paste. This time I'll make a withdrawal, but this time I'm going to make a withdrawal of $900. Okay, what do you think is going to happen? All right, I created a bank account, 500. I deposited 300, so now it's 800. I withdrew 100, so now it's 700. Over here, I tried to withdraw $900. And I can make this, I could come up here and make this better and say you tried to withdraw $900. It is insufficient funds. Because it looked and it said 900. If 900 is greater than 700, well, print insufficient funds and get out of here then, because you don't have enough to cover it. Okay? And as you can see, the balance is unchanged. Because I tried to do something I couldn't do, but my balance stays the same because it's 700. Okay? So that's the idea when we're talking about object orientation. You try to create a facsimile for something in the real world. I have a bank account. When I first set it up, I have an opening amount that I give the bank that it creates my account with. I can always get my balance, be it at the cash machine or be it at the teller or whatever. And then I can make a deposit, or I can make a withdrawal. And you could actually see it getting more complicated. And if it were like interest-bearing savings, you could see running a savings thing every month, and it would increase the balance by whatever percentage, and boom, boom, boom. So, and this, believe me, this is how code works now. This is how bank code looks. As simple as you may think it is, a lot of banking code works like this now. Yeah, I mean, you won't be having a simple instance variable. It'll be something that's kept in a back-end database. But as far as the code is concerned, blah, blah, you're looking at it. I mean, this is what happens with a simple bank account. Okay? You create a class that is a facsimile for something, and then you instantiate it. You get a variable, and you create an object, and then you use that object to do your business. Okay? So it's kind of different. It's like we used to have data, and then we would run things on our data to get to our results. Now we kind of do it together. We have our data in our object, and there's only certain things you can do with it. But that's kind of true in the real world too. So a lot of people think object orientation is closer to the real world, and we don't really have to abstract and represent and symbolize things as much when we do things in an object-oriented fashion, okay? You get in your slides the dice example. You get the student account example. Then I give you in this video the bank account example. Next video we're going to get a completely different example. So I'm going to do what I usually do is I usually do dogs and cats and animals the next time around, which fits nice into the two things we're going to cover, polymorphism and inheritance. But anyway, this is something where I want you to see a lot of example. I'm sure you're seeing different things in Zell. I haven't. I have to go back and look at the Zell chapter. I forget some of the examples that he uses. He uses the dice, I think. I want you to see as many examples as possible to see this work and to see this going. And so you get the gist of it, and you understand, oh, when you do object-oriented programming, it's because you're going for this, and it's because you want to do this, okay? Bank.py, it's going right up into Sakai. You got no worries about that, all right? Announcements, I'm not going crazy on announcements because I'm doing 2 more videos this weekend. I'll kill you at the end of the 3rd video. What I really want to mention for announcements is if I'm you and it's this weekend, do your proposal. Make sure you get me your proposal for your final project, because really fast, Sunday or Monday, I will review them and get them back to you, because I know you're stuck now. You can't move forward without me approving your proposal. So I'm going to do that as soon as I can. I can't do that unless I have them. Okay. Now, a lot of groups have already handed them in. I think I have 4 or 5 have already handed them in. So that's fine. You're in good shape. Like I said, this weekend's going to be a marathon for me. I'm doing Python. I'm doing more Python tonight. I'm also watching Blacklist on Netflix. I'm in the middle of season 3. Lizzie just dyed her hair back to, well, no, I guess she washed her hair out because she was blonde. And then, oh, shit, I don't want to do any spoilers for you guys. But a main character changed her hair color. That's where I am. I'm in the middle of season 3. No spoilers. And it's getting good. It's a good show. I like it a lot. So I usually don't watch it on real TV because I'm never in the same place at the same time every week. And I don't know what I'm going to do. And I kind of like binging, you know. I kind of like taking a 20-episode season and watching 6 of them, then watching 4 of them, then watching 5 of them. So that, because I hate commercials. There's no bigger waste of time on the planet than commercials. Are you really going to buy a truck because you see a commercial? Because you see some weird guy, you know, putting trucks on pedestals and all that? You got to be kidding me. Who buys things when they see, and they must work. They spend so much money on these commercials. Who buys things when they see commercials? It makes me bananas. Anyway, it's Python all weekend with a little Blacklist. But mostly it's Python all weekend, all right? I'm doing these videos. I'm going to grade your midterms so I can, you know, I'm looking forward to reading all those papers. I love it because those, you know, when everybody does the Learn Python the Hard Way and does the Code Academy, does the MIT, some people are old school and they're like, I like watching a classroom thing. And some people are all new and Web 2.0 and say, I love Code Academy because it's interactive and blah, blah, blah. So I'm looking forward to doing that. So I am, hopefully by the end of the weekend, going to get you your midterm grades and send them out to you. I want to get going on your Unit 4 grades too. So I want to do those quizzes. I want to do those forum posts. Logic Called Joe is a good story, right? It was written in the 50s. 50s or late 40s? I forget. But my God, could you imagine being so prescient? And we have things like that right now. Like I'm sitting right next to my Echo. Hey, Alexa, Describe the programming language Python.
I can't find the answer to the question I heard.
Of course you can't, because you're a silly little cylinder on my dining room table. You need to be a Python programmer to understand Python. But I digress. So anyway, I'm not going to kill you with announcements. Worry about the proposal. Get me the proposal. I'll get you the thing for that. Last thing I'll leave you with is exhale. Relax. Because it is November 18th. We have more than a month to do Unit 5 and Unit 6. And Unit 6 is a piece of cake. Unit 6 is just a survey. I realize you're working on your final project. It's not that difficult at all. Okay? You're going to have Thanksgiving break to do a lot of Unit 5 stuff. Okay? I will get you the assignment for this pretty early. It'll be either Sunday night or Monday night, so you have it. Okay? When you first see it, you're going to feel like you have been thrown into the deep end of the pool. All right? It's the idea. You'll be fine. Don't worry about it. Okay? All right. Then I'm getting out of here. You're going to see me tomorrow because I'm doing your Unit 5 review video 2 tomorrow. So hopefully I keep moving and getting you all of your resources. All right? So you can get moving on Unit 5. Unit 5 is a fun one. Unit 5 is always a fun one. People like it. People like it a lot. All right. Then I'm getting out of here. You be good. I'll talk to you tomorrow. All right. Bye.